Hi all. Today we are going to see about couplings and its types. In detail, we are going to see about the design procedure of Muff coupling. Okay, let's get started. So this is the definition of coupling. As you know that coupling is a device used to connect the two shafts or two pipes together. It may be a permanent or semi-permanent connection. Okay, these are the requirements of good shaft coupling. So I have listed some of the good requirements. It should be easy to connect or disconnect. It should transmit the power from one shaft to another shaft without losses. Okay, so it should hold the shafts in perfect alignment, and it should reduce the transmission of shock load. So shock load is the one of the losses. It will be reduced from one shaft to another shaft. So it should have no projection parts. If there is any projection part, there will be a losses. Okay, so it should have no projection parts is the mandatory thing. So let's move on to the types of couplings. We have major two types of couplings. One is rigid coupling and another one is flexible coupling. So what's my rigid coupling? So rigid coupling, it is used to connect the two shafts with perfect alignment. So this is the rigid coupling. Its name implies there is a reason for rigid is permanently it should be joined. Okay. So for flexible coupling means there is we need some misalignments or we need some lateral connections means we're going for flexible coupling. So flexible coupling is nothing but it is used to connect the two shafts having both lateral and angular misalignments. So rigid couplings, in rigid we have also have three uh, types. So one is sleeve or muff coupling. In particular, in today's class, we are going to full detail see about the muff couplings. Okay, so muff coupling is also called sleeve coupling, and there is another type called split muff coupling or compression coupling. So another one is a flange coupling. So commercially, we use flange couplings for many purposes. So let's see in further classes. So in flexible coupling, we have also three types. One is boost pin type coupling, another one is a universal coupling, another one is a hole-up. The hole-up coupling is the special couplings. So the entire design procedure, which is available in the data book, in page number something, I will update in description. Okay. So let's move on to the design of muff coupling. So in muff coupling, we have three meeting parts. So one is muff. So another one is key, and another one is the shaft. So is the the important thing to connect the shaft. Okay. So we have some terminologies. First one is capital D. So capital D is called the diameter of the muff, and small d is called the diameter of the shaft, and capital L is called the length of the muff couplings. Okay, so length of the muff couplings is calculated by the formula 3.5 into D. So D is nothing but the shaft diameter, and capital D is the diameter of the muff, which is calculated by using the formula 2D plus 13 mm. Okay, so these are the formulas which is available in the design data book. You can directly see there. So in design of muff coupling, we have three steps. So one is the calculation of shaft diameter, so which is nothing but the small d. Okay, using the torque formula. Another one is design firstly. So design firstly in the sense, so we need to calculate the capital D, so which is the diameter of the muff, and we need to calculate the length of the muff, which is nothing but the L is equal to 3.5 into D. Okay, so this is the torque formula for solid shaft, and this is the torque formula for hollow shaft. Okay, so in torque formula, so torque is nothing but the pi by 16 into tau s into d cube. Okay, so tau is nothing but the shear stress of the shaft, and torque is nothing but the number of revolution. Okay, so this torque is calculated by using the power formula, or maybe some cases torque and css values also given in the particular sum. Okay, so using the torque and shear stress of the shaft, we need to calculate the diameter of the shaft, which is nothing but the small d. Okay, so this formula is used to calculate the calculated for shaft which having hollow section. Okay, let's move on to the next part. So this is the key. So key is the an in between part which is connect for the muff as well as shaft. Okay, so in key we have so many types: saddle key, sunk key, parallel key, taper key, and all. So in key there's a chance for failure is due to the crushing stress of the key and shear stress of the key. So crushing stress means in order to in during running there is the compression between muff and shaft. So in between we have a key, right? So there is a chance for compression there, and as well as shear. So shear due to the rotation of the shaft, it may be the key may be subjected to the shear. Okay, so in order to calculate the length of the key, small l is equal to l by 2. So in some cases there is a assumption is provided, so which is nothing but the key is taken as square. Okay, so just the breadth and the length of the thickness of the key is same. Okay, so a small l is the length of the key, which is used to calculate the formula capital L by 2. Capital L, as you know, that the length of the muff. Okay, so uh, in the listed formula, we also check the check under the crushing and the CSS also. So in given the maximum limit of the shear and compression is given. So, okay, so due to that value we need to check, it may be a check for the reason of failure or not failure. So design is safe or not safe. So these are the things we need to propose. Okay, so let's move on to the problem. Okay, so in problem we need to design the muff coupling for the following data. So I will read the problem. Design and make a neat sketch of the muff coupling, which is used to connect two shafts transmitting 40 kilowatt. So the power of the shaft is power of the this is 40 kilowatt at 350 rpm. So 350 rpm is the rotating thing. Okay, the material for the shaft and maybe the key is carbon steel for allowable CSS and crushings maybe. So as you know that I will I told, right? So 40 megapascal is taken as the maximum limit of shear, and 80 megapascal is taken as the maximum limit of crushing. So this is nothing but the compression stress. Okay, the material also given. The material of the muff coupling is cast iron, and allowable CSS of the muff is 15 megapascal. This is the CSS of the cast iron. Okay, so these are the given data. You could clearly see that. Okay, so first we need to calculate this diameter of the shaft. Okay, so as you know that the torque formula is P into 60 divided by 2 pi n. So in this formula we used to calculate the torque. Okay, so torque is nothing but the 1100 into 10 power 3 Newton mm. So okay, we need to, so actually the formula, the unit of the torque is 1100 Newton meter. So we need to convert in millimeter. So so 1100 and 10 power 3. So we need to multiply 10 power 3 to convert the Newton meter to Newton mm. Okay. So using this formula, the diameter of the shaft is calculated. Let's move on to the calculation of sleeve. In sleeve, as you know, the diameter of the so capital D is the diameter of the muff or sleeve, maybe. So D is equal to 2 small d plus 13. So in this formula, we used to take the formula in data book, as I already I pointed out. So tau c is nothing but the CSS of the sleeve. Okay, so here the given CSS of permissible is 59 Pascal. So as you know that we calculate CSS 2.97, so which is less than the permissible, so the design of MOF is safe. So it may be proposed as it may be safe. Okay, so next one is design for key. So as you know that the design for key, so we taken the key, the cross section of the key is square. So T is the width or thickness of the shaft. So which is taken as 18 mm. Okay, next these the width of the key is taken as 80 mm for the shaft diameter. So this is standard value which is taken in data design data book. Okay, so using this formula, so using the torque formula, we need to calculate the shear stress of the key. So using this formula, we have to calculate the crushing stress of the key. So in CSS there is the value 22.8. So the actually the 40 Newton, the maximum permissible CSS is 40 Newton per mm square, which is given in the problem. So which is the 22.8 is the less than the 40 Newton per mm square. So the design of key is also in safe limit. Okay. So and similarly the crushing stress of the key also in safe limit, which is 5.6 is the calculated value, and the given value is 80. So 45.6 is the less than 80 Newton per mm square. So the for the checking of crushing stress, this also in safe limit. Okay. So since the in conclusion, since the induced CSS and crushing stress are less than the permissible stress, so therefore the design of key is safe limit. So this is the way to design the muff coupling. So in later part, we will see the flange coupling, boost pin type coupling as well as. Okay, so thank you, thanks for listening. Okay, thank you, bye.